back to LearningStrome Academy. So friends, if you haven't pressed the bell icon or you haven't subscribed our channel, so please subscribe it right now so you can get directly our videos to you. Okay, so let's start with float data types, which is the topic that we are going to discuss today. So friend, what is the float data type and why the languages need float data type? Okay, so friend, actually the purpose of the float data type is that we have ample conditions when we need to represent our when we need to deal with the number with the decimal point numbers. Okay, now if I want my program can also deal with such kind of values, so we need a particular kind of data type which is compatible to decimals number. Okay, so friend, now we need a data type that is compatible to it. Okay, so float data type actually friend is a data type which is compatible to with the which is compatible with the decimal numbers. Okay, actually when float data type actually used to represent the number which is number in it with the decimal points. Okay, so friends, floating so what is the purpose of float data type? Actually it is used to represent the decimal point numbers. Okay, so friend, actually how much memory it takes? So friend, actually float data type takes 4 bytes to store the data. Okay, so friend, actually float data we use this single precision. Okay, so friend, what is the meaning of precision here? The meaning of precision, friend, the number of digits after the decimal point. Okay, so friend, it is going to use this single precision for the accuracy of their program. Okay, so it's mean that it is going to represent 6 to 7 digit. Okay, 6 to 7 digit after the decimal point. Okay, so friend, okay friend, so which format actually it is used by the Java folding by number? So friend, before the Java we have languages like C and C++, which makes the program machine dependent. Okay, so friend, and before the Java now we have like machines like Intel, we have machines by AMD. Okay, we have processor. They define the format of floating point number by their own way because they are independent to each other. Okay, so different machines define the format of floating point numbers in their own manner. Okay, but friend, this is challenge for Java. Java want to make a program portable or want to make program which is machine independent. Okay friend, so friend, there is a need to define a particular standard which is followed by each and every machine. Okay, for Java program. Okay friend, so just because of this a standard that is known as IEEE 754 floating byte standard is defined, so that each machine is going to represent a number in this format. Okay friends, so actually what is this format? So let's take a look to this format. So friend, actually now Java is going, this format is going to divide at 32 bits into 3 parts. First bit is a sign bit, another part is our exponent, which is going to represent the exponent part. Okay, it actually takes 8 bit. Okay friend, and the next part is our mensisa. Okay friend, it is going to take 23 bits. Okay friend, so what is the purpose of sign bit and exponent and mensisa? Let's discuss it. So friend, sign bit is actually used to represent the number, either it's positive or either negative. Okay, the sign of a number. Okay, so what is the friend, so what is the meaning of exponent? So friend, the meaning of exponent, the power. Okay, number of time a number is going to multiply. It's mean that if I'm going to consider my number 2 into 10 raised power 3. So friend, 3 is here the exponent. Okay, this means that my number is going to multiply by 3 times. Okay, and the rest part is going to consider as a mensisa. Okay? This is a scientific notation of a floating point number. Okay, so generally my number is going to store in this format in our by the Java compiler. Okay friends, so this is the main representation by our Java compiler. Okay friends, so let's take some example of the floating point number. Okay, so friend, first of all I would like to friends see, we are going to get an compile time error. Okay, the error is, okay, the error for which we are looking is the we are unable any compatible types. possibly lossy conversion from double to float. Okay, actually my compiler is unable to convert my actually my compiler is treating this number as a double. Why, friend? Why my compiler is treating this as a double? Just because, friend, actually whenever we are assigning any decimal number to any floating point number, okay, if I'm not proceeding it, okay, with f, okay, then my compiler is going to treat it as a my compiler is going to treat it as a double number. Okay, friends, so that's why my compiler was unable to compiler was unable to typecast the double value to float. That's why my compiler is raising an error that incompatible type, I am unable to convert double to float. Okay, so that was the error, friend. Okay, so from here it is clear to you all, if we are going to consider any floating point number without the f, okay, prefixes f with it, then my compiler is going to think that it is a double number. Okay, and then my compiler is going to treat it as a double number. Okay, so friend, so whenever we want to work with floating point number, then it is mandatory to prefix it with the f. Okay, friend, sorry, proceed it with the f. Okay, so this is the first point that I discuss with you. Okay, so another that I am getting is here what. Okay, actually I'm trying to print f, which I made it comment, that's why I was getting an error. So friend, what is the highest range that my compiler can see, friend? Now, okay, friend, we are going to get an error that floating point number is too large. Okay, friend, so friend, now it is clear to you all what is the maximum range for a floating point number. Okay, so friend, what is the minimum range for it? So friend, the minimum range for it is if I'm going 3.4 minus 3.4 e to the power 38. Okay, so now you can see this is the minimum range that it can be represented by. Okay, so this is the man, friend, how to take a floating point number. Okay, what is the minimum range and what is the maximum that I discussed with you. Okay, so friend, I want also, so see friend, here Java compiler is representing only 7 decimal, 1 2 3 4 5 6 7. Okay, 7 digit after the decimal point. So friend, now it is clear to you that my Java compiler actually represents 6 to 7 decimal place after the decimal point. Okay, after decimal point. Okay, this is the precision value of the floating point number. Okay, now friend, if I am going to in my account z, okay friends, if I want to check it, let's compile it. Okay, friend, now you see, friend, my compiler is not printing my all values again after the decimal point. Okay, and not even the 7 values of 1 2 3 4 5 6 7 8. Okay, not even not printing the all values. Okay, friend, so friend, now you can see that my compiler is actually rounding off the values. Okay, so friend, that's why it is my recommendation to you all, if you are working with the project which is related to some monetary fund, or which is related to some transaction, then you should try to use the big decimal class of the Java. Okay, which is actually meant for such kind of application, because actually as the behavior of the floating point number is not that definite. Okay, actually sometimes it rounds off your values. Okay, sometimes it is not going to give you your value to your accurate value as you assigned. Okay, so this is some it gives always some variations. Okay, just because I would like to prefer you to use the big decimal class whenever you are using some kind of monetary applications. Okay, friend, so these are the way cases that I need to discuss with you. Okay, so friend, what are the application of float data type? Actually, friend, the application of the float data type is ample. Actually, friend, float data type are used within the real numbers. Okay, so if we talk about real world, we oftenly use the real numbers in many cases, like in calculations, in data analysis, in statistical techniques, in mathematical equations, in physics equations, and to represent time, fractions, money amount, etc. Friend, so friend, if you want to see the application of real world, you can use, you can see in any you can see any real world example. And here we definitely we are dealing with some kind of float numbers, okay, decimal numbers, okay. So when in all these cases we can use the floated type, okay. So when okay, so what we can, as I discussed with you, we can represent a number with accuracy level to 7 digits, 6 to 7 digit decimal digit, okay. Okay friends, so let's summarize all the topic. So for actually first bit of a number represent what sign of a number, okay, and the next 8 bit is going to represent but actually exponent part of our number, and the next 23 bits of our number is going to represent a floating point number of our floating point number. So friend, so maximum value of my floating point number is 3.4 e raised to 38. This is the maximum value that my floating point number can represent. So what is the minimum value? Minus 3 the point 3.4 equals 38. This is the minimum that my floating point number can represent, okay. So friend, as I discussed with you, float point represent 6 to 7 digit after the decimal point, friend. So thank you for watching, and keep subscribe and like us video, okay. So okay friend, bye bye.